Hi folks, welcome to another Wednesday Widget. We have a ton going on at the shop right now. The lathe came, it's been a weekend full of putting that together, which is awesome. That involved reorganizing the shop. We had a hiccup with the tractor, so I had to swap out the antifreeze. We hung the new jet air dryer, so a ton going on. We've got jobs coming in all at the same time, and I'm trying not to turn any down, but nevertheless, got to do the Wednesday Widget. While I was working on a job just the other day, I noticed I've been missing one of my gauge blocks from my gauge block set. That's only a Char set. It's not the best gauge block set out there, but nevertheless, I know it, I trust it, I like it, and I want to replace that missing piece. You can buy one from McMaster for 25 some bucks and maybe cheaper elsewhere, but hey, let's make one. Shouldn't be too hard at all. So I've got a little piece of 4140. We're going to whip it up in SolidWorks real quick, cam and sprue cam, machine it on the Tormach mill, and then hop over to the Tormach grinder, and we're going to grind it. And all throughout the episode, we're going to talk a little bit about measuring, whether it's calipers or micrometers, or in this instance, what we're really going to use is a surface block or granite block with a height gauge to really get what I think is the most accurate way. And we don't have a 107 block, but we've got a 106 and a 108, so we should be able to get halfway between it and know with dead nuts on at 107. So let's dive right in. Okay, new part in SolidWorks. We're going to sketch on the front plane our gauge block, and these are all 1.15 by 0.355. That's the footprint, and then obviously the thickness will be the one that we need. So we are going to feature extrude down to 0.107. We're missing the 107 thou gauge block, and that's our little part. So let's go ahead. That's all the SolidWorks we need. We'll hop into Sprue 9 and change the orientation of this guy. Actually, you know what we'll do? We'll add the workpiece first. So under workpiece here, the piece of 4140 I've got is primitive bottom southwest point. It's a 1.5 by 0.75 piece, and it'll be a lot deeper than that. We'll call it an inch deep or something. And the point will be 0, negative 0.75, and negative 1. And that gives me our workpiece. Now let's move our CAD model over, or centered rather, in the workpiece itself. So transform will come over point, let's see, what would the math be on that? Well, it would be 1.5 minus 1.15, so 0.35 divided by 2 would be 0.1, about 1.5, excuse me, and down about 0.2, I think, negative 0.2. Oh, sorry, we got to come down 0.355 minus 0.2 gets us to the center. There we go. That looks about right. And now I want to change. I'm above my Z-plane to get that flush, so negative 0.107. That's what I wanted. Okay, so pretty simple. We'll just do a 2D contouring around these 4 lines. Curve, and I'm going to do a go-to recipe, which is for me tool 30, which is a 1/4 inch carbide 4-flute coated end mill. We'll go 2,700 inches a minute, so RPMs 12 inches a minute, and we'll come down. Now, so that's the question. We want to come down more because we're going to have to bandsaw this part off and then surface grind the bottom. So we'll come down plenty. We'll come down to 0.2, and we'll do that in 3 passes, just for, that's very conservative, but just to be conservative. And we're going to probably need to rough it 0.1 here, 0.09. And we'll do a finish pass of, say, 5 thou. Let's see what that looks like. Okay, maybe too conservative. We'll give it a shot. We'll do a little bit of a ramp in here and simulate. Looks good. You know, I don't mind the roughing out an outer layer, but I don't want to cut it in 3 depths of cut. That's too wimpy. So let's do it in 2. There's the cleanup. Now remember, the dimensions we're cutting here don't really matter, of course. What really is going to matter is the distance between these 2 faces, both to be accurate and flat or parallel. Okay, so that looks good to me. We're starting outside our workpiece. We can set an approximate XYZ0, XY0 rather. So let's head over to the Tormach, got to make some chips. Okay, I've got the workpiece in the vise. I want to show you guys though, I have raved about the Superfly before. I've always used it on aluminum with the aluminum insert. But I've had the steel insert for a while, and I just threw it in there. Holy smokes, folks, you're about to see. I'm incredibly impressed with the results. We're only going to take a very shallow cut, probably 10 thou, but we're going to run about 1200 RPMs and 7 inches a minute and just clean off the face of this material. Check out the surface finish there, folks. You can see, there you go, you see my finger in that. It is just unbelievable in my opinion. Okay, let's grab our other end mill here. And I set 0 with that, so all we're gonna do, we've got so much extra material, there's no reason not to just eyeball this, so we'll call that XY0, good enough. And I'll usually scroll around here and I'll double check my Z. Just eyeballing it, that looked good. And just double check as I jog through and mock. Try to keep an even chip load, if you will. You know, looks good to me. Okay, let's rock and roll here. I really like working with steel, and I just don't do it enough for no good reason other than so many jobs come in aluminum. But even though it's harder, you know, maybe it's a little bit less forgiving. Man, you realize when you cut a lot of steel just how gummy aluminum is, and it's really, really nice. And look, even 4140, it's really easy to machine. You know, as you guys know from my little video playing around with stainless, you know, there are definitely steels that are harder and frustrating and higher stakes, but so many free machining steels. I mean, even 1018 or G's, you can do a job with like 12L14. That is a lot of fun to work with. But I really enjoy it, and obviously being able to hop over in the grinder, hopefully, knock on wood, we're going to turn out with a nice part today. Speaking of hearing that noise, I am excited on the project list to get the air compressor. I've decided I'm going to leave it inside, but move the intake and exhaust pipe outside. Here's the cleanup pass, by the way, just 5 thou, I think we said. That should, I guess it's the intake, the compression of the air as the piston is pulling it in, is really what creates the noise. So hopefully being able to source the air from outside will actually let the whole compressor, tank, and head stay inside, but reduce the noise a lot. Okay, part's done. Let's take a look. Looks great. Again, really love the finish we're getting from that Superfly. As you can see, the reflection of my finger there Really nice. Okay, so I'm gonna go cut this off in the bandsaw, and then I'll see you guys over at the surface grinder. Okay, we're over here at the grinder, and I'm gonna skip through a lot of stuff. If you wanna see more about grinding, I did a video where we tried to pick up the dicum off a piece of block, and you can watch that here. There's a little link to it. So I've already got my wheel dressed, and I need to leave the chuck on. Actually, interesting debate. I've heard some other folks that say that's a bunch of hogwash. I don't really care to get in a pissing contest about whether or not it's bad to turn your chuck off after you've dressed your wheel in, or whether you need to redress it, but interesting debate nevertheless. So I've got some marks set up here where I have my stops set. Another somewhat interesting debate, and again, this is even touchier, is how close you're allowed to have your hand to the wheel. And I'm not looking to start off a safety debate, but I've heard some folks that say never, ever, ever near it, but then there's a sort of conundrum, well, if you're not allowed to turn the wheel off, you know, I can only pull my table out so far. And I would also counter, if this was all the way up at the top, you know, it seems lower risk. So a little bit of just a common sense type of thing. So got the part in there. I usually try to feel it to make sure you can feel if there's a chip or anything under there. It'll rock around. Put your magnet on, come on over. Make sure I try to make sure my indicator is out of the way here before I lower it down. That way I don't over travel the indicator. It's a tenths indicator, so it doesn't have a lot of, I think the total range of motion is only 50 thousandths. So what we're going to do is just get it something, we're just going to get this ground flat, and then we're going to flip it over and grind that edge flat with as little grinding as we can do, and we're going to measure it and see where we are. We obviously hope we're above 107. If we're not, we'll have to start over. We should be. And then we'll start grinding down to get the precision we're looking for. So the way I usually do this is just slowly down. The wheel's only on the back edge of the part, and I kind of just come down here. I'm looking at the light, and once I start to see the light disappear, yeah, it's close to, well, yeah, it's close enough for now. Now, I was, you know, taking a step back, as like maybe many of you are. I'm not formally trained, and I never had used a surface grinder for a long time while I was machining, and I thought, well, geez, you could machine within a thousandths tolerance, and you guys just saw the finish we got off the Superfly. Why would you need to grind? Well, grinding is a lot more accurate. It's a much different process with an abrasive. And remember, unlike that mill where we've got lots of different things that can go out of tram, here we've got a chuck that's been ground in place, and that's it. So there's far less things, vices, tables, fixture plates, etc., tool deflection that can cause changes. So you're going to see a much accurate finish. We should be able to control it within the tenths, not without much problem. And so accurate and really good surface finish. So now I've got my selector switch on. We're just going to travel back and forth, and now I go ahead and start to preload my indicator, and I watch. Now I'm just looking for sparks. There's a little spark on the side. It's good enough. Now I'm going to change patterns, and we'll take one pass. This may not do much. In fact, I've got too much travel set. It is a little tricky on this machine to set it for a really short Y travel. I'll fast forward through some of that stuff for you, sorry. Coming back up on the part right now. You could do it by hand to fix that. Okay, so yeah, it was just that little right edge, so we'll come down a thou or so, thou and a half. Just, again, trying to make sure we're not getting crazy. Let's zoom in on this too. We're not quite all the way flat, but you can actually see, it's really cool, you can see some of those bandsaw chatter marks, if you will. I don't know what the technical term is. Come down a little more. There, we're just about clean, not quite. This should be Let's see, the final pass I got to do on this side. Okay, I'll take a few more tenths just to, this is sort of a spring cut or cleanup pass. Sometimes guys talk about letting it spark out. Okay. Sorry, my battery's died on my microphone. But we shouldn't do much sparking here. Yeah, just a little bit. Not even, if you can see, they're not even actually completely grinding that, which tells you it probably wasn't perfectly flat. So I'll come down half a thou. And that should get us flat. God, I love grinding. I've really fallen in love with it. Okay, so I'm good that it should be a flat and parallel part. So let's go over to the surface plate. Okay, so here we got a little part. Looks good. You can see that's a nice finish. Let's see where we're at. We're not going to be close yet, I'm sure. Okay, so the calipers say 120, 119.5 or so. These are not particularly accurate though. I use them daily, but for this kind of work they're not accurate. So this, I'm going to show how I would do this. There are probably 1,000 ways to do this, but it's actually, we're going to see how accurate it is right now, but also this is how we're going to hone in or dial in the exact part. So in my gauge block set I've got a 120. So we'll take that 120 piece and we'll slide it under our Starrett back gauge indicator. Okay, so we're at 30. Let's see if that repeats. Should repeat. Hope it repeats. Yep, right at 30. So let's slide our piece under there that we measured at 119 or so, and I'm getting actually 2 thou over that. Okay, well, no big deal. Let's just confirm that. So let's grab the 122 piece and see if that hits 32. It should. Just sort of triangulating here. Yep, perfect. So I would say right now that our little piece that we've got is 122. So we wanted 107, so we got 15 thousandths to come off. That's a heck of a lot in grinding. I'm going to go shave a little bit more off. I'll be right back. I just shaved 10 thou off on the grinder, so that should mean we're at 112. So I got a 112 gauge block here. Let's slide it under, and that puts us, we'll make sure that's right on 25 thou over. Again, this is just a comparator now, not a measuring tool, if that makes sense. So grab our piece, and hopefully this is at 25. Yep, maybe, you know, a quarter thou over. Now, on that note, this is only a thousandths indicator. I wish I had a half thou or tenths even, but my half thou one, I'm ashamed to say, I broke it this morning. We were moving things around, setting up for the lathe, and it fell off, and there's no other good excuse other than I broke it. So sorry, folks, but this should get us, it should do the trick for today. And sometimes you got to work with the tools you have. So I need to go, I'm at 112, I want to go to 107. So I need to take 5 thousandths off. So let's head back over to the grinder. Okay, I'm going to lay my part back down in the exact same spot on the grinder. Feel it for any wiggle, none there. Lock it down. Now, we've got this indicator here, and it's actually coincidentally just about on 0. So what I'm going to do for the purpose of this video, I'm actually just going to do this manually. So we only have a few thou to go. So I'm going to take a thou at a time. So come down a thou and just manually crank the wheels. Come down another thou. And I'll take one more, and then we're going to go measure. I'll come down just a tenth and do a cleanup pass. Okay, let's go measure this, see where we're at. Okay, now we really got to start paying attention. I've got 2 gauge blocks, the 106 and the 108. I'm missing the one in between. Let's do this. Let's slide the 106 under the plunger, and let's set that to -1. Nice and easy. Just make sure that repeats. Perfect. Repeats very, very well. Now, the 108 ought to be +1. We agree? Sure enough, +1. Awesome. Now, we left 1,000, so we should have 108 right here. So it should be +1. It is. Maybe a couple tenths more. That's perfect. So that's important because it does us no good to come in on our final 1,000. If we can't get to this point accurately, we're never going to end up accurate. So I'm going to go back over the grinder. I'll be right back. I'm just going to shave that one last little 1,000th off this guy. Okay, I shaved 1,000th off. We're going to see what we get. I swear, I've not tried this yet. So I positioned the indicator so you guys can see a little better. So we may have to reset it a little. So let's slide the 106 under there and see. That is, you know, a hair shy. Try not to touch it. So let's use this guy. Sometimes it's just a question of how you read these things. So that's 106. Slide the 108 and see if we're +1. Yeah, you know, it's funny. I am, but the camera makes it look a hair shy. Well, let's just see what we get. Look at that. That's awesome. That is awesome. Okay, now the first takeaway I will admit is you shouldn't use a thousandths indicator to measure something that you're trying to dial in perfectly to a thousandths. You really should use at least something like a halfths indicator or even a tenth. They're not expensive. Again, I broke mine, not a good excuse, but I want to be upfront about that because I know I don't want to offend any engineers or people who overthink this stuff, but I agree. But hey, look at that. Look at that snap on there. Tell me that's not cool. 106, under, 108, or 107, on, 108, 1 over. I am happy with that. And then take a look, folks, look. We got our 3 little sticks here. Let me focus in on them. Look at that. You know, mine doesn't have a little marking on it, but pretty darn cool, right? They looks great. Oh, the surface finish, guys. If you haven't seen grind, I mean, when you buy like 1 to 3 blocks, they're solid ones, they're ground. Lots of things are ground, but it is just awesome. So I hope you guys have enjoyed that Wednesday widget. Hope you've learned something good to take away. Stay tuned. I'm going to be releasing the first lathe video any day. Otherwise, folks, take care. See you soon. Thanks for all the enthusiasm and responses and RSVPs at the open house. I think it's going to become a great event. Otherwise, I'll see you next Wednesday for the widget. Take care, folks.